All right, new lesson. We're going to be talking about properties of numbers, and this lesson is kind of more about just getting you to break down your thinking and understand that you have to work sequentially and you have to work systematically when you're solving problems and when you're doing any kind of thing like that. So, what we're going to do with this is we're going to have you you'll work with your order of operations, but we're going to have you justify each step. And the way you're going to justify those steps is you're going to use these things called properties. And a property is kind of like, it's like a law. It's like kind of something that says whenever you do this, you can expect this to happen, or this is okay because of blah, 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 and whatever. So we're going to, this particular video is going to talk about sort of the introductory properties that you're going to talk about. And I'm just full disclaimer here. I'm kind of assuming when you're watching these videos that you're also having looked at the packet, right? So that you have looked at the packet. And I think the videos work better if you've read through the packet already. Okay, so make sure you're doing that. Because then hopefully the videos can answer some of the questions you might have from reading through it. And if the reading part's a little hard for you, I get it, but just look through it at the best of your ability, and then watch these videos, and then I think it will be most effective that way. All right, so introductory properties. Let's look at a few of these. So these first four properties, I'm going to be completely honest with you. You're pretty much really, for most of what you do in this class in algebra, you're pretty much only going to ever use the substitution property. All right, you need to know reflexive, symmetric, and transitive, but they're pretty straightforward. Reflexive property, I think of like a reflection, right? Any quantity is equal to itself, all right? Of course, all right? And there are some times actually when you use that, but that's not going to be the case for most of the problems you do. Symmetric property basically says, if A equals B, right, then B equals A. All right. So if you can prove that one thing equals another thing, then if you run into that other thing, we know it equals that one thing. Okay, and this sounds kind of like a no-brainer, like sort of like, duh, why do we even have a property for that? But we do. All right, it is important to be able to justify it and give it a name, and so they call it symmetric property. All right, and then transitive property is extending that one step further. So it's kind of like saying that if I'm as tall as my brother, and if my brother's as tall as his friend, then I'm as tall as my brother's friend, or my brother's friend is as tall as me. All right. So if hopefully that kind of made sense. All right. So if A equals B, and then if B equals C, then A equals C. So you will on occasion run into that here and there, but not too often. Now this last property you're going to actually use. This substitution property, basically, I think of it kind of as like the simplification property. So when you're going through these problems and you get something where you just have to multiply regular numbers or subtract regular numbers or add regular numbers or whatever it is, and it doesn't fall into one of the other properties we're talking about, that would be substitution. Okay, so now let's look at the other properties, and then I think what I'll probably do is pause this video and then have a second video, like a part 2 for this. This one says the sum of any number and 0 is equal to that number. So this is called the additive identity, and I think they another name for it that you'll see in earlier books is the addition property of 0. All right, so it just means that if you add 0 to anything, it doesn't change it. An additive identity is saying you add something to something else, but it doesn't change the identity of that thing. Well, the only way that can happen is if you add 0. If you add anything else, it will change it. But if you add 0, it won't. All right, so there's some examples off to the side here, and you will need to kind of remember what this is called. And then one that gets confused with it a lot is additive inverse. So additive inverse is different because you're not adding 0, you're adding something to something else that makes it equal to 0. So your sum is 0. And the only way that can happen is if you add the opposite. So for example, if I have 8 and I want to add something to it and I want it to equal 0, the only way I can do that is if I take the opposite of 8, is if I do negative 8. So we call those additive inverses. All right, negative 8 is the additive inverse of 8 because I can add it to it and it kind of undoes it and it makes it equal to 0. All right, so you've got your two addition properties. You've got your identity property, which means you add 0 to something, it doesn't change it. Then you have your additive inverse property, which means that you add something to something else and then you get 0. So they're similar, but they're not the same. All right, they have different functions. All right, and then the last three properties before I pause the video and we start again on a second video. Multiplicative identity. So multiplicative identity is basically if you multiply anything by 1. All right, if you multiply anything by 1, it doesn't change it. So this is similar to the additive identity. Additive identity, the only way that happens is if you add 0. Multiplicative identity is when you multiply 1. Similarly, there is something that is a multiplicative property of 0. So think about it. What happens when you multiply anything by 0? It makes it 0. So that's a useful property from time to time. All right. And then the last one here we have is multiplicative inverse, and it's related to additive inverse, except that instead of wanting to get to 0, we want to get to 1. All right. So what this says is no matter what number you have, supposing I have 7, I'm saying there is a multiplicative inverse that I can multiply by it that will get me to 1. And that number is always the reciprocal of this number. And we call that the multiplicative inverse. So if I have 7 and I write it as a fraction, 7 over 1, if I multiply it by 1/7, you get 7 over 7, which is equal to 1. And that gets me to this 1 that I want, all right? If I have 2/3 and I decide that what do I multiply by that to get 1, then the multiplicative inverse of that would be take the reciprocal of it, which is 3/2. Similarly, if I have a negative number, supposing I have negative 1/2, the multiplicative inverse of that would be negative 2 over 1, or negative 2, because I need that negative times that negative to make it positive. That gives you 2 over 2, and that's equal to 1. So multiplicative inverse, just think of reciprocals, all right? Think of reciprocals when you're multiplying, and then you'll be in good shape. All right, we're going to pause the video, and then we're going to come back with part 2, and we're going to see, we're going to put some of these in action.